So if we apply mesh analysis to this circuit, we should identify that there's two meshes. This loop here on the left that contains the 5 amp current source, the 10 ohm resistor, and the 30 ohm resistor. This loop here on the right that contains the 30 ohm resistor, the 20 ohm resistor, and the 25 volt source. So two meshes. Remember, the outside loop is not a mesh because it contains other meshes. And so two meshes. Okay, so if we identify our two meshes as A and B, then our two mesh currents will be IA in a clockwise direction and IB also in a clockwise direction. Okay, so I can start off by saying that for mesh A, I can define the voltage across this current source as like V1, Vx, V5 amp, and I could write my KVL loop equation based on that. But to simplify our solution here, we should start off by saying that for mesh A, we can come to the conclusion that this 5 amp current source comes out of the top and goes left to right through the 10 ohm resistor, and that agrees with the direction of IA. And so we can start by concluding that IA is equal to plus 5 amps. And again, that simplifies our solution, because now when we, if we wanted to find voltage drops in here, for example, we know the current through the 10 ohm is 5 amps. We know the voltage drop across it is 50 volts. So we don't need to write KVL for that loop. Okay, so let's think about KVL for mesh B then. So for mesh B, we should have already identified our polarities on here. Positive on the bottom, negative on the top, positive on the left, negative on the right. And for the 30 ohm from the IA side, positive on the top, negative on the bottom. So that one has opposite polarities on each side, just like we expect. All right. Okay, so mesh B, start in the lower left-hand corner. And our first voltage here that we're going is at the 30 ohm from the IB side. And so that's subtract 30 times IB. Now we got to have two terms for that resistor. So for the IA side, with respect to the direction of IB, we're going up. It's a negative to a positive. So it's plus 30 times IA. And I'm just going to leave that as IA for now. So next we come to the 20 ohm resistor. It's subtract 20 times IB. And then we come to the 25 volt source. And the direction of IB, we're going down across that. So that's a negative to a positive. So that's actually an increase in voltage, plus 25 volts. And that brings us back to our starting point. That sum is equal to 0. Okay, so remember now that IA, I got my cursor lost, IA here, we know that that's 5 amps. So IA is not an unknown in that equation, all right? And so what that means for us is that we should take that into account now when we simplify this equation. So we have then negative 30 IB and negative 20 IB, negative 50 times IB is equal to 25. We bring across the equal sign, negative 25. the 30 times 5 is 150. And we bring that across the equal sign, we make that negative as well. And so on the right hand side here, we have negative 175. So IB is equal to negative 175 divided by negative 50. And so that is equal to 3.5 amps. And so one equation with one unknown, like I said, simplifies that solution greatly. And so now, we have IA equals 5 amps, IB equals 3.5 amps. And we don't know the voltage drop across the 5 amp source, but we could find it if we wrote KVL around this loop, of course. Now, the answer to the question here was IX. And so realize that IB was defined as clockwise around this loop here, which means then through the 20 ohm resistor from left to right. And it came out with a positive value. So that means that IX as the opposite direction from IB. So IX is equal to negative IB. So the answer to the question is IX is equal to negative 3.5 amps. And so remember that we put the negative sign in to remind us that a direction for IX was assumed, but the current through that 20 ohm resistor actually goes in the opposite direction from what was assumed.